Okay, this video is to kind of prepare you for the final exam. And I'm hoping to be able to get some of you back who have kind of gotten lost in logic. Chapter 7 is different from a lot of the stuff that we've done before, so if you haven't, it doesn't have anything to do with fallacies or anything like that. If you haven't gotten some of this stuff before, don't get discouraged because you can do some of this stuff if you just pick up right now. So I'm going to go through the 4 parts of Chapter 7. Part 1 is the basic truth tables. You guys get your notes for your exam, so you don't have to know them, I guess, but it does help make everything a lot faster if you do memorize these highlighted lines for each one. So let's go through them. For conjunction, that's when you see an and sign or a dot. You memorize that it's when you have a T and a T, it's going to be T. Any other combination will be false. Disjunct, when you have the either or scenario, you're looking for the pattern of FFF. So if you have FF, you know it's going to be false. Otherwise, every other possibility is true. Conditional statements are the if-then statements. The only thing you have to memorize here is TFF. Everything else is T here. And then for biconditionals, when they're the same, so if they're both true or both false, they're considered true. If they're different, then they're false. And then negation is just doing the opposite of whatever it is that they've given you. Part 2, calculating truth values with designated truth values. That is when we use our tables that we have here to work out problems where we know what the truth values of the individual simple statements are. So they tell us what is true and what is false, and then we work it out from there. So P and Q are true, so I'm just going to mark T under them. R and S are false. False. I'm going to carry down all of the operators, and then using my trusty tables here, I'm going to work these problems out. So for disjunct, I'm looking for this pattern, FFF, otherwise it's true. It's not an FF, so it's true. I'm going to put it right underneath that operator that I just used. And I'm bringing this T straight down and this operator straight down. And then we have this problem. So we have a conjunction. We're looking for the combination of TT for a TTT. Everything else is F. So that whole statement is true. Next. P's are true, R's and S's are false. Carry everything down. Left to right, working out tildes and inside parentheses first. So not true is false. Keep that tilde there. We're going to work out what's in here first. We're not going to need more parentheses though. So disjunct, we're looking for FFF, and that's what we have. And then we're going to bring it down here. Go ahead and negate that. Now we have a conditional, which is TFF. Everything else is true. It's not a TF, so it's true. The whole statement's true. And the last one here is our if and only if, P and Q. So we're going to do labeling, bring down, and then left to right, inside parentheses first. We're just going to bring that straight down and then work this out. It's a conjunction. So we're looking for TT combo for a true, everything else is false. So we have a TT combo, so it's true. And then now we do the biconditional. So we know that these are true when they're the same. So it has to be true, true, or false, false in order for a biconditional to be true. These are different, so this whole statement is false. I need to pause. Okay, so part 3 is learning how to build the tables with up to 3 variables. And then we use these tables to calculate truth values without designated truth values, so where they don't give us what is true and false down here. We don't have that information, so we have to look at every possibility for any statement that we are examining. So we calculate truth values. We determine types of statements. There are 3 types: tautologous, self-contradictory, and contingent. We'll go over those. And then we use tables also to compare statements, 4 types of statements, comparisons between statements: logically equivalent, contradictory, consistent, or inconsistent. And we'll go through that too right now. Okay. So build truth tables to calculate truth values for the following statements. If you want, you can go through and build a whole table. I guess I just like to work it out here, but I also write pretty neatly so I can keep track of it. So we only have 2 variables. We're only going to need, I guess I'll build it because you guys need to learn how to build a whole table. Okay, so we have 2 variables, so we need 4 lines. And then we're also going to write the problem in there: 1, 2, 3, 4. Okay, so x or y, and y, if y then x. This is bad. I do a much neater job when I just write. Okay. So we assign the first half t, second half f to all of the x's. TTFF, TTFF. The y's get that pattern cut in half, so TFTF. And then we go left to right, inside parentheses first. For disjunct, we're looking for the FFF. All other scenarios are T. And then we work this one out. This is our main operator, it goes last. We're looking for a TF pattern. No, no, yes. So we've got 1. So we do a TFF, everything else is T. We're going to use this column and this column to come up with this column. And it's a conjunction. So our rule there, we're looking for T to make TTT, everything else is F. So TT, TT, no, no. So these are F, F. So this whole statement, we're looking at the truth values of just the main operator column. So there's 3 possibilities. Let's go through this really quickly. If all of these statements are true, it's called tautologous or tautologous. If they're all false, then it's called self-contradictory. If it's mixed, at least 1 true and at least 1 false, then it's contingent. So this statement is contingent because we have both T's and F's in our main operator column. So let's do the next one. So I'm just going to write them underneath, you'll see. So the first variable gets first half T's. We have 3 variables, so we need 8 rows down. Second half F's. Cut the pattern in half for the second variable. And then in half again for the third. I usually use lined paper when I'm writing these out. Okay, then you go left to right, inside parentheses first, and then we have to work this tilde out before we can even do the main operator inside the parentheses. So we just negate each one of these. We're negating the R, so. And then we'll use this one and this one to come up with this one. It's conjunction, so we're looking for a TT pattern. TTT. No, 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 yes. No, no. So these are all F's. And then we will use that column and this column to come up with the main operator column. And it is a disjunct, so we're looking for the FF pattern. There we go. There's 1, there's 2, there's 3. Everything else is T. Main operator column, we have a mix of T's and F's, so that statement is also contingent. Okay, a couple more here. Now we're going to compare statements. So I'm going to do the same thing. Building a truth table, I'm going to do it the same way I did it up there. We have 3 variables, so we're going to need 8 lines. First half are going to be true for the first variable. Second half false. Cut the pattern in half for the second variable, TTFF. Got out a line there. That's not good. TTFF. And then the third one, you cut the pattern in half again. You really have to keep track of where you're at here because you can get lost. Left to right, inside parentheses first, we're looking for TT for the conjunction. So TTT, TTT. No, 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 no. These are all F's. And then we negate it. So we negate the whole column. FF, and then T is all the way down. So now we use this column and this column to come up with the main operator column here. It's a disjunct, so we're looking for FF. One there. That's it. Everything else is T. Okay, and then we'll build them for this table over here, or this argument over here, statement, sorry, using the same truth values from over here. So all the Z's get the TF pattern right off the bat. Okay, TF all the way down. All of the X's have the TTTT, FFFF. All of the Y's have the TTFF pattern. Left to right, inside parentheses first. We need to negate these tildes before we can even do that operator. This is our main operator of the statement. So negate all of these. And then all of these. And then do inside parentheses. So disjunct, we're looking for FFF, FFF. The rest are T's. And then we'll use this column and this column to come up with this column. And it's a disjunct, so we're looking for the FF pattern, so we can do an FFF. And that's it. Everything else is a T. So main operator column here, and main operator column here. We're comparing statements. There are 4 comparison possibilities. So you're looking under the main operator columns for both statements. If they are identical, they're logically equivalent. If they're opposite on every line, identical on every line also. I didn't finish doing this. Contradictory. At least one line is true on both. Those would be consistent statements. And no lines true on both would be inconsistent statements. So here we have a T and a T and F, and then T's all the way down. They're identical. So these statements are logically equivalent. Okay, part 4 is determining the validity of an argument using truth tables. So valid or invalid using a table, building a table, and then using it. So let's try this number, well, I don't know, not number, but part 4. We have 3 variables, so we need 8 lines going down. And I am going to use line paper on this one. Okay. So first variable gets first half t's, second half f's. Second variable that we see, you cut that pattern in half. And then the next variable you see, you cut the pattern in half again. Nothing goes below these weird lines, but it does separate premises and then the conclusion, which we know. So all the z's get the same pattern. TF, TF, all the way down. All the x's, same pattern. Y's, TTFF, TTFF. Left to right, inside parentheses first. Conjunction, we're looking for TT, T, TTT. Nope. And then the main operator of this statement here is this. So we've got to work all this out first. So we negate this column here. So that becomes an F, that becomes an F. These become T's. And then we use this column and this column to come up with our main operator column, which is a disjunct. So we're looking for the FF pattern. FFF. No, these are all T's. So everything else is T. I do kind of write my letters bigger as I go so they can stand out a little bit better. Next column, we just negate everything in this first column. And then conclusion, do the parentheses first. So we're looking for TT, T, TT, T. These are all F's. And then this column gets negated here. So this becomes an F, F, and then all of these become T's. So we use the main operator column from each premise and the conclusion. And we're looking for all true premises across and a false conclusion, right? So we're looking for TTF basically. No, 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 no. So this is a valid argument. If we had a T here, and an F here, it would automatically be invalid, even if you just have one. All true premises and a false conclusion renders it invalid. So that is our review for the final exam. This should also help you with some of the quizzes. So I hope it was helpful.